This video is going to finish off 8.2, which is about comparing two means. So if we can do a hypothesis test to figure out if two means for two different groups, a mean for group 1 and a mean for group 2 are the same or not, then we can also do a confidence interval. However, the confidence interval has to be about the actual difference between our means, because that's the only thing we know the distribution of. So it's going to be our x1 minus x, or x1 bar minus x2 bar. So we've got a formula here. We have our point estimate. So here's what we think the difference in the two means is, plus or minus a margin of error, which is our critical value times some standard error. So the standard error formula is given above. And just like before, we are going to go ahead and just do this with technology, because again, they still have that same degree of freedom formula as a simple version, just using that minimum of our sample size is -1, whichever sample has a smaller sample size. But the actual formula is another super complicated formula that we don't want to have to do. So we're going to stay away from that, and we're just going to use technology to do this formula for us. So again, we have another example here. We've been given all of the actual data, the summary statistics, and we want to find a confidence interval. So we're going to go back to StatCrunch. And I didn't write anything down, which was insane, so I need to go back again to here. All right, so I'm going to write these down on my sheet. So we need an N of 43, X bar of 21.57, and S of 3.87. Then the other group is 33 versus 20.38 and 3.91. And I guess I should actually read the question. So we're going to test the effectiveness of a drug for treating bipolar depression using this depression scale. So this is probably a scale like 1 to 10 or something. So we have a placebo group, and we have a group getting the medication. So this scale, obviously not 1 to 10 because the average is 20, but we can see the average in the treatment group is a little lower than the average in the control group. And our question is just, is that enough of a difference that we could say perhaps the treatment is working better? And theoretically, to me, that's the question I would actually want to know. I would be really interested in looking at a hypothesis test of, is the mean for the placebo the same the same as the mean for the treatment? I guess I'll use control and treatment. Or alternatively, is the mean for the control greater? I can't write anything that I'm saying. Greater than that for the treatment, right? Because the higher the depression score, the more depressed they are. So we want to say that using the control with nothing, with a placebo, that they're more depressed than they will be with the treatment. So this is what I would actually set up if I were doing this question. However, we've been told to go ahead and find a 90% confidence interval for the difference between our treatment and placebo. Now, since we've been given a direction here, or an ordering, difference between the treatment and the placebo, what we're trying to find is a confidence interval for the mean of the treatment minus the mean of the placebo, or the control. For this one, I actually like the other ordering of it, so I'm actually going to set it up this way. And the reason I'm doing this is exactly what Maya said in the 3rd class, is that it's nice if we can take and have this be positive as opposed to negative. So we can say, oh, they're going to be this much higher on the depression scale, the Hamilton depression scale, without the drug. So I'm going to set it up in that direction. So I'm going to use a placebo as group 1. And we're going to just do this with technology. So again, we're doing a t-stat on 2 samples, and we only have the summary statistics. And again, we're just going to go ahead and enter in all of our data from those 2 samples. So I'm going to connect my keyboard so that I have life a little bit easier. So the first sample, our mean was 21.57, standard deviation was 3.87, and there were 43 people. This is the people in the control group who got the placebo. And then the ones who got the drug, which I have not tried to pronounce for a reason, there's our mean, our standard deviation, and there were 33 of them. We don't want to pool the variances because, again, we can't say that those are the same even though they're dang close. And we're going to go ahead and do a confidence interval at a 90%. So let's go ahead and do this. So it shows us that the difference between the two groups was a 1.19 on this scale. Gives us our standard error, our degree of freedom, which again, calculated using a gross formula. And then we have our actual interval. So our actual interval is from negative 0.3121 to positive 2.6921. So we'll go ahead and write that down on the page. So negative 0.3121 to 2.6921. So if we had to write out a sentence about this, we would say that we're 90% confident that the true difference in the average Hamilton Depression Scale score between the treatment and placebo is somewhere between these two values. So remember, you just want something about difference. You do want to have something about the word average that's sort of missing from in here. It needs to say average somewhere in here so that we know we're looking and comparing those. But this is the piece that I was concerned about us seeing before the final. Is based on this interval, is there statistically significant difference between treatment and the placebo? So just like before, we're looking at the actual test. So in this case, to test that control is equal to the treatment, and our alternative, although we would probably be interested in the one I said before of being less or greater than the treatment, just not the same. Is there some difference between them? And remember, I could write this as the actual difference. If they're the same, the difference is 0, or the difference doesn't equal 0. So 0 is the thing that we're looking for inside of our interval. Since 0 falls inside my interval, it is possible that there is no difference, right? The fact that this goes from negative to positive here says that the treatment is worse than nothing at all. Actually makes them more depressed by 0.3 points, and here the treatment is better. So without more information, right, without a larger sample size, we cannot say anything. We would fail to reject the null. We don't know that there's enough evidence. Doesn't mean that they're the same, just means we don't have enough evidence to show that they're different statistically. Right? Obviously, we saw a 1.12 difference, so a point reduction based on the treatment, but not enough that it's statistically significant. And this is actually how drugs are put onto the market, is they do something, they usually would do the hypothesis test as opposed to a confidence interval, but they have to meet very strict guidelines for a p-value and then be replicated many times in order to go on market.